In this video, we're going to start to look at the last thing that this class is going to teach about, which is something called arrays. So an array is the simplest form of a category of mass data storage options called collections. It is easiest to imagine an array as a long box with individual cubbyholes, like mailboxes, for each individual data element. Each cubbyhole will have its own address number called an index. So just to show you a visual example of what this looks like, imagine something like this. So this whole thing represents an array, and it's comprised of a whole bunch of individual cells, or what they call elements, and each one of those elements has its own address number, address 0, 1, 2, 3, 4, etc. So each array index, those are these numbers down here, is an address that holds one piece of information. Although the indices must be integers, what you put inside of here that you're going to plan on storing could be any type of data. So it could be an intrinsic type, like an integer or a double or a Boolean or a character. But it could also be user-defined objects. So you could put an entire bank account in here or an entire dog object. Most importantly, notice that the indexing number, the addresses, always start from 0 with arrays. Like with anything else in Java, before you can use something, you have to declare it. So let me show you how to declare an array. First, you start out by saying what type of variable you'd like to store. Then you're going to put a set of square brackets, left and right, and then the variable name. So for example, if you did int square brackets myArray1, you have just declared that you're about to create an array that's going to hold integers, and the name of the array is going to be called myArray1. Likewise, you could create an array of bank accounts. So this is saying the type of variable is going to be bank account. It's an array because we have square brackets, and the name of the array is going to be ACC1. The trouble, though, is with declaring something, because this is an array is a user-defined object, you don't actually have any memory to store it with yet. So if you only declare these arrays, they're empty and they have no memory values assigned to them. So if you tried to use either of these arrays right now, you'd get something called a null pointer exception. Just like we did when we tried to use a user-defined object and never ran the constructor and never said the word new. So we're saying we're going to have arrays, but we haven't actually provided any memory locations in the RAM for that yet. So what needs to happen next is we need to instantiate the arrays, which is when you actually assign memory locations to the things that you're trying to create. And we do that by using the word new. So just the same way as we would creating any other type of variable. So if I now took my array1, which I've already declared up here, and I set it equal to new int brackets 15, this tells Java I need 15 integer type memory locations, and the word new is asking for that memory to be set aside in the RAM. And then it gets assigned to my array1, which we've already declared. So this would create the 15 memory locations needed for this array. And likewise, I've already declared a count type array ACC1, but I haven't asked for any memory yet. If I ran this line of code, I'm asking for 3 memory locations of the bank account type to be assigned to ACC1. So this would create the 3 memory locations and then assign it to ACC1. So the way that I declared and instantiated the arrays in my previous 2 slides was kind of clunky. I want you to know that you can declare and instantiate all on one line of code. So you can do int brackets myArray2, that's declaring you're going to have an integer type array called myArray2, and you can instantiate it new int square brackets with a 23 inside. So this is telling Java It's asking for 23 memory locations to be assigned to this array. So this actually is declaring and instantiating all in one line of code. So when you do your codes with arrays, you're probably going to just take care of it all at once. When you first initiate the array, the compiler needs to fill these, in this case, 23 memory locations with something. So what it does is it fills those memory locations with something called a default value. So here are the different default values for the different types of variables that you might use to create an array. If you're using an integer, a short, a long, a byte, if you're using any of those types to create an array, your default value is automatically going to be 0. So it would fill the entire array with zeros. If you're using double or float, which are things that are expecting decimals on the end, your default value is going to be 0.0. For a char type variable, if you use that as the variable type for an array, your default value is going to be single quote /u and 4 zeros. That is the default Unicode for character. If you're making a Boolean type array, the default value is going to be false, so it would fill the array with all falses. And if you have any user-defined type object that you're using to create an array, like for example, if you want to create an array of bank accounts, all the initial values for all the bank accounts would be set to null. So null is the default value for any user-defined type. Now, if you happen to know all the values that you'd like to go into your array, and you don't want to have Java put in default values for all the spots, you can actually assign them immediately upon creation by doing the following thing. If on the left-hand side of the array, if on the left-hand side of the equal sign, you declare what type of array you want, put the square brackets to indicate that it's an array, and the name of the array, and then on the right-hand side, you can actually, inside of a set of curly braces, assign all the values that you'd like. So what this would actually do, this one line of code, will tell Java there's going to be an integer type array. It will tell Java that the name of that array is going to be array3, and it will immediately fill up that array with these values. So your array will learn how many memory locations it needs, and also the values to fill it up with all at once. So the compiler gets the correct size and the correct elements into this array all at once. So if we actually did this line of code, I want to show you a visual of what this would look like to Java. At index 0, it would get filled up with a value of 2. Index 1 would receive 4. Index 2 would receive 6, and so on and so forth all the way down the line. Now, if you count this up, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 values. But take a look here, the indexing, even though there are 10 values, the indexing goes from 0 to 9. One of the things to pay attention to here is that your highest index number is always one less than the total number of memory locations that you have. So if you have 10 memory locations, your highest index is 9. And the reason for that is because you're actually starting to count from 0, which is unusual. We usually start counting from 1. So when you get to working with arrays, there might be a time when somebody passes you an array that you didn't make. So maybe they made it, or maybe the array was made somewhere else. One of the things that you might not know but want to know is how big the array was. In other words, how many memory locations did it have? So Java provides a feature that allows you to access the number of elements by using the public length field variable. So it's a public variable, which means you won't have to run through an accessor method to get it. So let's say you created this array, and its name was array3. If somebody else made this array, not you, and you don't know how big it is, you could actually do something like this. Int y equals array3.length. So this is going to take array3, which was this one that we created up here, and figure out how long it is. It will tell me the number of memory locations for this array. Now look, if you're going to do that on the right-hand side of the equal sign, you've got to have a place to store it on the left-hand side. So int y is going to receive the value that the array3.length command is going to go get. And in this particular case, we counted this up before, there were 10 memory locations. So the value of y after this line of code right here would be 10 because there are 10 data elements in this array. So that's it for today's notes. This is about how to create, instantiate, and fill up an array with values that you'd like. Tomorrow's notes are going to be on how to work with an array.